Hello my people, welcome back to this video session. This day is about conditional probability. Conditional probability, firstly, you have to know that this works for two dependent events. So we'll talk about conditional probability as long as the events are dependent. So we cannot talk about conditional probability for independent event. No, we are working with dependent events, and therefore from there, that's where conditional probability arise. Now, dependent events, these come from two dependent experiments. Dependent events will occur from two dependent experiments. This goes opposite with independent events or independent probability. So actually you need to have two experiments or more than two experiments which depend on one another, and from there you'll have dependent events, and probability associating with this kind of event is what we call conditional probability. So actually let us define dependent event. By definition, I am saying that dependent events are two events such that the occurrence of one event actually depends on the occurrence of another event. What does this mean? Is that if the second event is to occur, that means there must be the condition that the first event occur also. So if there is a sequence of events which depend on one another, let's say those events are two, the first event and the second event. If the second event is to occur, that means the first event must occur first in order to trigger the occurrence of the second event. In this way, we say that the two events depend on one another, and especially event 2 will depend on event 1. A perfect example which will make you understand a bit more on dependent event is this one. Check an example coming from random selection. Let's say you are doing a random selection multiple times, maybe 3 times, 4 times, whatever. Now, so what I'm saying is that the first selection, no, so this one is not the first. Correction first, correction, here correction, second, here first. Now, what I'm saying that from random selection, the second selection comes after first selection, and we expect also third selection to come after second selection has been done. In this way, these kind of selection depend on one another, and events resulting from this kind of selection will be now referred to be dependent events. And our interest for this session is to know how to find probability of dependent event, and that probability is famously known to be conditional probability. Why conditional? Because there is kind of a condition that arises, or can say a term. It's like a rule that in order for the second event to occur, maybe the first should occur first, or in order for the third event to occur, the second should first occur. And in that way, things have been conditional, and therefore the probability arising from this kind of event is now described to be conditional probability. So now let's continue our trying now to digest or analyze the formula that is suitably used to find the probabilities of dependent events. Let's check that. Now, suppose, audience, suppose that A and B are two dependent events such that A to occur depends on B to occur first. Assume this, that you have got two events, A and B, such that in order for A to occur, therefore B must occur first. So from there, you can say A slash B, A backslash B, this will represent or will mean event A given that B occurred. So to write this way, we mean that event A occur given that B will occur. So this backlash is representing this word given that, in the sense that we condition that for A to occur, B must occur. B must occur. So we are conditioning by using the word given that. So event A to occur given that B has occurred. So in this notation, we can also write B given that A. So this means B given that A, in the sense that in order for B to occur, A must occur first. And therefore, if we write probability of A slash B, this means probability of A given B has occurred. And similarly, P of B slash A will mean probability of B given A has occurred. And these represent conditional probabilities. We are saying condition because one event must occur first. So it is conditioned that must occur first in order to trigger the second event to occur. Now with this notation, let's check the formula that is suitably used to find the probabilities of conditioned event, or probability of two dependent events. Let's check this formula. So now you have got a formula. You have got this formula. The probability of A given that B has occurred is supposed to be given as a ratio of probability A intersection B divided by probability of B. Now my audience, this is the formula which is used to find the conditional probability. Here you can see this formula is for A to occur given that B has occurred first. But also you can try to modify this formula if B occur whenever A occurs first. So you can write this formula that probability of B to occur given A supposed to be probability of A intersection B given that A has occurred. This denominator, we put denominator basing on this conditioned event. So we put this denominator basing on what is written here. If here is A, then you plug there A. If it is B there, so we plug B there. and the numerator remain the same. The numerator remain the same is a probability of A and B to occur both. So with this formula, we are going to do examples to see how we can use this formula to answer some kind of question which might be theoretical or practical in a real life situation. Okay. Now you've got example number 1 with given information that the probability of an event A is 0.5, the probability of B is 0.6, and the probability of A intersection B equals to 0.4. Now you're asked to find the probability of event A given that B has occurred, and also probability of B given that A has occurred. So now, for item Roman 1, you have to introduce the formula that from the probability of A given B has occurred, which is defined to be probability of A intersection B divided by probability of B. So things now becomes easier after you know the formula. What you need to do is to plug the information here. So probability of A intersection B is given here to be 0.4, and probability of B is given to be 0.6. If you simplify this fraction, you get 2 out of 3. That's it. This is probability of A given B has occurred. Roman 2. Roman 2 is probability of B given A to occur. So the formula change. Probability of B given A will be equals to probability of A intersection B divided by probability of A. So again, you substitute the information. The probability of intersection is still the same, divided by the probability of A, which is now 0.5. So simplifying this one, you get 4 out of 5. This is probability of B given A as occurred. Let's check example number 2. Wow. With example number 2, talking about a card which is drawn at random from an ordinary pack of 52 playing cards. It is given that given that the card is red. Given that the card is red, find the probability that it is number 7. So here, what the question is asking you is to find the chance that the card picked will be number 7, but should be red. So you can see there is condition that while you are trying to find the probability that the card is number 7, you have to consider the fact that the card is red. The card should be red. Now, so to solve this question, first you have to let A to represent number 7 as even, and B to represent red card as even. Okay, so from there, we need to know the number of A intersection B, which means number of cards which are 7 and red. Number of cards which are 7 and red. Actually, from a pack of 52 playing cards, there exist 2 cards which are numbered 7 and red. Red card, there are 2 types. It might be diamond card or hat card. So there will be number 7 hat, number 7 diamond. Those 2 cards will be red and also numbered 7. So probability, the number of sample space is 52, and therefore probability of A intersection B will be given as number of A intersection B divided by number of sample space. And this becomes probability of A intersection B to be 2 out of 52. That will be the probability that a card is 7 and at the same time it is red. Now we need to find the probability that a card is red. The probability that the card is red, you have to take number of red card over number of sample space. Now how many red cards from available 52 playing card? So actually red card, they are a total of 26 out of 52. Out of 52. Now, so here now you can come back to the question which asks find the probability that a card is number 7 given that it is red. So question is that you have to find the probability that a card is number 7, event is A, given that the card is red and event of red is denoted to be B. So given B. And this by definition will be the probability of A intersection B divided by probability of B. So if you plug the information, you will have this one, which is 2 out of 52 divided by 26 out of 52. If you solve this math, simplifying this mathematics, you will get 1 out of 13. So that will be the answer, 1 out of 13. Let's check example number 3 to finish the section. Alright, check this example number 3. Probability that A occur given B has occurred first is 0.4. And if the probability of B to occur is 0.2, find the probability of both A and B to occur. Now, here you have to break down the information given. The given information is that the probability of A to occur given B to occur first is 0.4. So you can symbolize that one as probability of A to occur given that B has occurred first, and this probability is given to be 0.4. So actually this conditional probability is given already to be 0.4. Now another information given is this one, that the probability of B is 0.2, and the question asks you to find the probability that both A and B will occur. So this means you have to find the probability that A and B to occur equals to what? So with this information, because now you see the existence of conditional probability, that means conditional probability formula will apply. Now we introduce the formula, so we say from the formula that probability of A given B, how was it calculated? How was it calculated? Was calculated by the ratio probability of A intersection B divided by the probability of B. So from here you have to plug the given information and solve for the unknown. So this probability is given to be 0.4, and this probability is not given, and it is the thing that we want to find. So you have to leave it as it is. And here the denominator is probability of B, which is given to be 0.2. Now 0.2. So to solve this one, we cross multiplication and becomes 0.0. It will be 0.08, I think, yes. 0.08. Yeah, with two decimal places, yes. So the probability of A and B to occur will be 0.08. We did 3 examples. I hope that they will help you a lot to at least understand the basics when it comes to conditional probability. Thank you for this time. Please continue subscribing my YouTube channel.